Our next topic of discussion is net acceleration in non-uniform circular motion. When we say net acceleration, it means there are two types of acceleration in circular motion. That is known as tangential acceleration. It is denoted by at vector, and centripetal acceleration, it is denoted by ac vector. So there are two accelerations in circular motion. When a particle is performing non-uniform circular motion, we have two types of accelerations. The resultant of those two accelerations is known as resultant acceleration or the net acceleration, or simply acceleration in circular motion. So acceleration in circular motion will be equal to square root of at square plus ac square. Why we have this type of formula? We will discuss. Suppose particle is at this point. This is the center. The radius is r. Now this particle is performing circular motion. The velocity of particle is tangential. It is linear velocity. The direction of linear velocity is tangential. Means we have to draw a tangent. We have to draw a tangent. Along that tangent, the velocity is. If particle is performing anti-clockwise, so this is the velocity. If it is performing clockwise, so this will be the velocity. Now over here, the particle is going along this circle. So after some time, this will be the velocity. So we can say this is v1 vector and this is v2 vector. So velocity is changing. The magnitude is also changing and direction is also changing. Both magnitude and direction changing. When we say magnitude of velocity, it is linear speed. Magnitude of velocity is also called as linear speed. So linear speed means the rate at which distance is covered. So the example of constant linear speed will be like this. It is moving along the circle with constant speed. So that is uniform circular motion if the speed is constant. If it is increasing with time, linear speed is increasing with time. So suppose initial speed is very less. Now it is increasing with time. Like this, it is increasing with time. So that is non-uniform circular motion. So when linear speed is changing with time, when linear speed is changing with time, so we have acceleration known as tangential acceleration. The formula for tangential acceleration is dv by dt. So this is instantaneous tangential acceleration. Now in uniform circular motion, it will be zero because speed will be constant. In uniform circular motion, we have discussed about centripetal acceleration. The centripetal acceleration is towards center. Centripetal acceleration is AC. The value of AC can be determined using V square by R formula, or we can have R omega square, because V is equal to R omega. So V square will be R square omega square. So AT and AC, the direction of AC is towards center. So when particle is over here, if the particle is at point A, so AC will be towards center. So we can say it is pointing towards west direction. And when particle is here after some time, So the AC vector will be towards center. It is pointing towards the center like this. And velocity is tangential. What is the direction of tangential acceleration? As the name suggests, tangential acceleration is also along tangent. So we have to consider whether the linear velocity is increasing or decreasing. If linear velocity is increasing, then tangential acceleration will be along velocity. So at this point, the tangential acceleration is parallel to linear velocity. So now we have two acceleration, AC vector and AT vector. AC vector is towards center, AT vector is along tangent. The angle between AC vector and AT vector is 90 degree. They are perpendicular to each other, so their dot product is 0. AC vector dot AT vector is 0 because angle between them is 90 degree. They are perpendicular to each other. In the next diagram, we will consider AC vector and AT vector when the particle is here. So this is the direction, this is the center. So direction of AC vector is towards center, and suppose the speed is increasing with time and it is anti-clockwise circular motion. So the velocity is this way. So we have acceleration AT vector also along velocity. So I am writing here, particle is going anti-clockwise with increasing speed or increasing velocity. With increasing velocity. So velocity is increasing. So that means tangential acceleration is along velocity. So this is the direction of velocity and this is also the direction of AT vector. After some time, velocity will be, suppose when particle is here, velocity will be this way. So AT vector is also along the velocity. So both are parallel. But in this diagram, I am not drawing velocity vector. I am drawing only AT vector and AC vector to show the resultant acceleration. So let's complete the parallelogram. Now we have two vectors here, AT vector and AC vector. These are the two vectors. Using the parallelogram law of finding resultant vector, we will consider the diagonal. This is A vector or the resultant acceleration. So A vector is the resultant of AC vector and AT vector. Since AT vector and AC vector are perpendicular, so we can say the resultant acceleration, the magnitude will be square root of AC square plus AT square. AC is the magnitude of acceleration, centripetal acceleration, AT is the magnitude of tangential acceleration. Now the resultant acceleration is making alpha degree angle with AC vector, or we can also say the radially inward direction. So tan alpha, so we have tan alpha over here. Tan alpha is equal to, now if you look at this parallelogram, it is like a rectangle. So we have opposite side of this rectangle equal to the magnitude of tangential acceleration, and the adjacent side is the magnitude of centripetal acceleration. So this will be equal to AT by AC. Tan alpha is AT by AC. So now let's do one question based on the formula of AT. AT is equal to dV by dt, and we can also apply the formula AT is equal to R alpha and AC is equal to V square by R, or we can also say R omega square, and tan where alpha is equal to AT by AC, and resultant acceleration magnitude is equal to AC square plus AT square, square root of that. Now let's do one question. If linear speed v is equal to 3t square on a circular motion, on a circular motion or circular path with radius 2 meter, find time after which centripetal accelerations and tangential acceleration both becomes equal in magnitude. So how to solve these type of questions? So first of all, it is a circular motion. The path will be circular path. The radius is given in the question. Now particle is performing circular motion like this. We can assume it is anti-clockwise. So the linear speed after time t. So we can say at t is equal to 0, speed is 0. So particle start from rest. After some time, the linear speed is 3t square. So speed is increasing. Speed is increasing. Let us suppose when particle is here, speed is 0. Let us suppose the time is also 0. So speed is 0. So the centripetal acceleration will be 0. In this case, centripetal acceleration is 0 because we know that centripetal acceleration is equal to v square by r. After some time, suppose particle is here, so it will have some speed, so its velocity vector is there, so speed is there, so it will have centripetal acceleration also, which is directed towards the center. So the length of AC vector is this, and we have tangential acceleration also. This is the tangential acceleration. So the length of tangential acceleration and the length of centripetal acceleration both becomes equal. So we can also say that the alpha becomes 45 degree. Now we have to find time after which this happens, this situation occur. So we will use the formula. So for AC, we have a formula V square by R. And for AT, we have a formula dV by dt. So V square by R is equal to dV by dt. Now using V is equal to 3t square, it is given instantaneous speed. So differentiate it, we'll get dV by dt as dV by dt is equal to 3 into 2t. So that is 6t. And over here V square, in this V you substitute 3t square. So we will get 3t square whole square. This is V square divided by R, which is 2, is equal to dV by dt, which is 6t. 6t. So solve this. This is 9. 3 square is 9. Then t raised to 4 by 2 is equal to 6t. Now solving this equation, 1t is cancelled. So 3 by 2 t cube is equal to 2. So t cube is equal to 4 by 3, or t will be 4 by 3 raised to 1 by 3, cube root of 4 by 3. At this particular time, the tangential acceleration and centripetal acceleration both becomes equal in magnitude. Now next question, if V is equal to 3t, find time after which resultant acceleration makes 60-degree with tangential acceleration. So in this particular question we have AT AC. When this situation occur, the resultant acceleration makes 60-degree with tangential acceleration. So how much angle it will make with AC vector? It will be 30-degree because AT vector and AC vector are perpendicular. So the resultant acceleration is making 30 with AC vector. So we have alpha is equal to 30-degree, and the formula for tan alpha is equal to AT by AC. Now tan alpha means tan 30, so which is 1 by root 3 is equal to AT by AC. Using the given information, which is given as V is equal to 3T. So V is equal to 3T. We have dV by dt is equal to 3. This is AT. So this is tangential acceleration. So we have 3 by AC. Now AC is equal to V square by R. So let us assume the radius is given as 1 meter in the question. So V square will be 90 square by 1. So we will substitute these values here. So we'll get 1 by root 3 is equal to 3 by AC, which is 90 square. So 90 square is equal to 3 root 3, or T square is equal to root 3 by 3 or 1 by root 3. So T will be 1 by square root of root 3, or we can say T is equal to 1 by 3 raised to